Algebra 3. We're going to try to cover as many questions as we can. Rather than showing you guys the answer key as it goes, just because we're going to be going through every single question, we'll talk about what our answers are. Let's see if I can get this up here. Let's see. On question number 1, at the guitar amp sale, Mahoney sold T amps for $M. I'm going to go ahead, because I've got this in hand, as I'm going to move over to a blank page where we can look at this. And this is a distance. It works like a distance, rate, and time question because it's a rate question. Okay. Let's see. So as we got this, let's see. Mahoney sold T amps for $M. Okay. So usually what we're talking about is dollars per amp. Okay. So if we've got, let's see, T amps for $M, dollars per amp, we're going to do $M, and let's see, what do we have? We had T amps down here, so our rate is M over T. Does that make sense so far? Okay. Now, we go to another place, and they sell for $15 less per amp. Okay, so technically that new rate is M over T minus 15. Okay, that's that new rate.
Oh. Would the 15 be the new rate or the denominator?
It'll probably end up going with the... Well, the way that we're going to end up using this is because it says how many amps could he buy for $3,000. So this is my rate, and we want to know how many amps we can buy for that amount of money. Okay, so we actually have to distribute the T to both of these. Technically, this is just minus 15 over 1. Okay, all right. Let's see, so as we, yeah, you're right, the minus 15 goes with the numerator, so technically we've got M minus 15 over T because the 15 represents dollars. Okay, so we've got M minus 15 over T. Let's see, times T. Okay, and because we just want to solve for this T, we're actually just dividing 3,000 by all of that, which, because we're dividing by a fraction, we're going to multiply by the reciprocal. So this T that we have right here equals 3,000 over 1 times T over M minus 15. Which is why we get an answer of 3,000 T over, I don't know why that won't go, over M minus 15 T.
That's the answer.
Yeah, and that's, I mean, it gets really ugly in there. Let's see. I'm trying to see from here why we have that T on the top. Or why we have the T with the 15. Well, I know that's what it comes out to. So that's what you're looking for there is 3,000 T over M minus 15 T. Okay. All right, let's erase this. Anybody have any other issues with that question? No? All right. Okay. Our next one, number 2. The goat runs through an arc of 70 degrees around the hitching post. How far did the goat run if he was 150 inches from the post? So what type of question is this? Arc length. So for arc length, we use 2 pi r measure over 360 degrees, right? So we're imagining, here's my post, the goat's at the end of a rope, and he's going around in a circle, right? Okay. So we're going to keep 2 pi. What's the radius here? 150 inches. Okay, he's not going all the way around the post. He's only going 70 degrees around the post. Okay, so my guess is, did anybody use anything besides that formula to solve this question? What's that? So you ended up using area instead of circumference, so you did like pi r squared. Okay. All right, so this is the formula that we want to use, and I'm kind of hoping at this point that unlike geometry and algebra 2, I don't really have to throw the calculator up on the board and show you how to do everything, right? I can tell you what the answer is, and it is 183.26 inches. So that's something that you want to check. Did you get that? Did you get that in your calculator when you plugged it in?
Yeah.
Right. If you didn't, right, you want to come back and you want to ask about that. Okay. Any issues with this question? Okay. Anybody besides Dylan have any issues with that? Okay. Well, no. My point was is that you answered for everybody, that nobody had any questions about it. I want to make sure that you might be right, but there might also be somebody that's not going to speak up because Dylan spoke on my behalf, right? Okay. All right. Number 3 gives you an equation. It wants you to graph y equals 1/3 to the negative 2x. I'd say the biggest thing to be careful with here is the exponent, because typically, well, I'll show you two different forms of this, and that they are not the same. At least I don't think that they'll come out the same. For 1, we can do, 1 divided by 3 to the, let's say I don't put a set of parentheses around that. Let's see how that affects it. Let's see if I don't put parentheses around my fraction and don't put parentheses around my exponent, versus if I put parentheses around 1 divided by 3 to the, and I put parentheses around negative 2x. Now, the one that I want to look for, the one that should end up being right in terms of an equation, should be my third one. Okay, let's just see how different they are, if they are different. Okay, there's our first one. Thinking. Still thinking. It may, yeah.
I think the first one was the same line.
Yeah, probably, and I don't know if we can.
The third one was hard to see because it's like inside of the.
I think your calculator's
Probably just there we see one. See, that's what I was looking for, and I don't know that we saw that on our previous one. So our first two are that first line. Okay, they don't come out as an exponential increase. Okay? The one that we're actually looking for is that exponential increase. Okay?
I think, I don't know, it feels like, I'll put the parentheses in right now. I'm not fighting about taking the extra parentheses. It's just, like my calculator, I put it in the 1/3 as parentheses, and the negative 2x is the exponent, and I got the same as the third point.
Well, it's because you gotta do it on ours.
Yeah.
Oh,
You can't
yeah,
go
that's
over it.
Right. So like on a newer calculator, whenever you hit that caret symbol, it leaves everything as an exponent until you hit arrow over, and then it drops it off from being an exponent. But on this one, you could see where as soon as you hit the caret, like, it's just whatever. And so if I have multiple things as an exponent, I have to group them using a set of parentheses so that I know that I'm taking all of it to that power. Otherwise, what it's going to do is it's going to take 1/3 to the negative second probably, but then it's going to multiply it by x. Okay? Or very likely, there's a possibility, I don't know, I have to see the difference. It might do like negative, or it might do 1/3 to the negative first times 2x. Okay, so it may not look at that as the same. So if you're asking, hey, what am I expected to show on the test? I want this and a table of values. I typically do, -3, -2, -1, 0, 1, 2, 3. And I know that looks like a lot, but all things considered, your calculator's doing all the work. You just have to copy some stuff down. I'm not asking you to be super specific with this, but it should show up as an exponential increase, right? Now, granted, on the test, it may be an exponential decrease, but you're going to represent it the way that it should be represented, okay? All right. So your values end up, -3 is 1 over 729, 1 over 81, 1/9, 1, 9, 81, 729. Okay. Any questions about number 3?
Do we leave the table values into decimals, or do you want them into fractions?
I'll probably take them as decimals. Okay? And I don't know if you can change the form of that so that it gives it to you as fractions. Like, I'm kind of curious to know if when you do that, like if you can hit math fraction and if it'll re-represent those as fractions. Because I'd rather see them as fractions because you see the comparison a lot easier between, 9 and 1/9 on either side of the 0, right? You can see that it's, that it's inverted, or at least reciprocal. Okay. All right, number 4. This again is mainly, how do I set up my calculator, but what am I going to show? So what I'm going to show in my on my paper for number 4 is 5p4 minus, 5p2, and I'm going to get a number. But again, I'm going to do this in my calculator, right? I'm going to do the work with the calculator. Let's see. How many of you? Hopefully, everybody got an answer in here. What did you guys get? Got 100. 100. What did you get? So you multiplied the 2 instead of subtracting. Granted, I guess I can just kind of show it through here real quick, just so we're familiar. But again, it's an older calculator, so on a newer calculator, it's not necessarily the same steps. So I have to go 5 math over to probability in PR. 4 minus 5 math probability in PR 2, and then hit enter and get that 100. Okay. But all I really need to show, granted, you could show a lot more. I mean, there are ways to show more work. If you wanted to show a whole bunch of work, basically what this is right here, this is 5 factorial over 5 minus 4 factorial. Okay, and then I take that answer, and over here I have 5 factorial over 5 minus 2 factorial. So I'm taking these two numbers, and what I'm getting here is 120 minus 20, which is actually the 100. Okay, so that's actual math that's taking place. Okay.
So you would accept the first one, though, right?
I'd accept the first one. Okay. Need another one?
No.
Okay. All right. Let's see. 5 has multiple parts. Our first one on A, we have 4 log base 3x equals 2 log base 3, 9. I'm kind of curious to know, what was your first step in here? Can't cancel out the logs until I move the numbers that are out in front of them.
Yeah, because I made 4 the exponent of x, and I made 2 the exponent of 3.
2 to the exponent of 3?
9.
Okay, so I want to rewrite that as log base 3x to the 4th equals log base 3, 9 squared. Now can I drop off the logs? Yeah, and what I'm left with is x to the 4th equals 9 squared. Well, we can simplify that again. X to the 4th equals what? 81. So really what I'm looking for is the 4th root of 81, right? Because if I'm just solving for x, I'm not just a square root, but the 4th root, and so x equals 3. All right, how many of you got 3 for an answer? Only...
I would have put out myself.
That's kind of the case for most of us, where we would have gotten the right answer if we hadn't messed up.
I did 4x.
Okay. All right, but we understand what we need to do to get here, and that's why we're doing all of this. So, all right, everybody on board here, we're seeing enough where we can write it down and be ready for tomorrow? Okay. Let's erase this one. I think this next one's easier. Log base 4, 1/64 equals x. What do you mean you just plug this one in your calculator?
You just log base 4.
Okay, so you went at it that route. There is a pencil paper way to do this. I at least want to show you that. Granted, there's probably about 3 different ways to do this. So, like method number 1 is if you have a log base function in your calculator, you can do this. So, that's just plugging in exactly the way it is. Another way to do this is do it as log 1/64 over log 4 will give you an answer. Okay. The other way to do this is to switch it over to exponential form. So that's bringing the 4 up, bringing the x over, moving the 1/64 to the other side. This is the way that I've taught you up to this point. All right, where we're taking 64 and making it 4 to a power. Okay, so we have 4 to the x equals 1/4 to the, I want to say to the third, because 16 times 4, I believe, is 64. So you get this, and whenever you move that 4 to the third up, it becomes 4 to the negative third. So x equals -3. It includes more steps. Okay, but that we've done that several times over.
Pencil paper way where we did it.
I would prefer that, because not everybody has that log base function in their calculator. I want to see real quick if if method number 1 that I have up there works, because I've not done that with this one. Let's see, let's take log 1 divided by 64 divided by log 4. See if we get -3, and we do, we get -3. Okay. I would say use your log base function, or even use number 1 with your calculator as a way to check your work for number 2. Okay, for doing method number 2. So show me method number 2, but you can do what you're doing to check and make sure that you got the right answer. Does that make sense? Okay. Okay. We got about 5 minutes here. Let's see. C. We got log x to the 32nd equals 5. This is one where you do need to change it to exponential form. There's no way to just plug that in your calculator. So the x comes up, 5 comes over, 32 goes to the other side. So you're looking for the 5th root of 32, right? Which is 2. X equals 2. Okay, so that's what we're looking for there. Okay. 6 also has multiple parts. You'll notice that it says do not use a calculator. Let's see where I'm looking at on 6. Where's my 6a? Okay. So it says arcsine 1. All right, now the easy way, you can use your calculator to check your answer. How would I check my answer for this? Inverse sine. Yeah, so if I want to check this before I even start to see how I'm going to do inverse sine 1, okay, it gives me 90 degrees. Okay, so let's check and see. Oh, let's see, what was it? Was it? All right, we're looking at A. All right, so we should get 90 degrees. All right, because we're talking about sine is opposite over hypotenuse, right? We can't have just the fact that it says sine there, so sine where sine is 1, well, where is sine 1 at? Well, sine represents which axis, x or y? No, the y-axis, okay? So that's 1, and that occurs at 90 degrees.
Oh, yeah.
Okay, see what I'm saying? That's all you got to show for that. Okay. B, let's see, arctan -1. Okay. Again, you can, check that answer, see what you're getting. Remember what we talked about when we hit this lesson, though, is that capital A on arctangent tells me I have to be either in the first or fourth quadrant, right? Okay. So what I'm seeing with -1 is that I have an opposite over adjacent that's equaling to -1. So that's either +1 over -1 or -1 over +1. Okay, where it's opposite and adjacent. Which in this case, there's 1, there's -1, which is going to be -45 degrees, which is going to match what you put in your calculator. Okay, so that's how I get -45. Okay, again, the handy part is that yes, you need to do more than just punch it in your calculator, but punching it in your calculator is going to verify your answer. Okay. All right, so we'll stop there. I'll try to keep going with the other class on this. And